All right, I'll go ahead and introduce myself. I'm Ryan Riley. I'm going to be talking about F# on the web, and specifically talking about what we've been doing at Tachyus. In the past, I've done a version of this talk, and it's always been related to like just things that I'm doing, things I'm trying out, and I'm so excited that I actually get to start sharing like real-world use of. Yeah, this isn't good to do the infinite drill down. Let me get to the presentation. There we go. So this is a revised version of F# on the web based on my experience working at Tachyus, and the agenda has changed some. We're now going to be starting with data access because any good F-sharper knows that most of what you're doing is getting some data, doing some stuff with it. In this case, we're just doing this via the web through some web APIs. I'm going to stop pretty much at the web API layer. I'm not going to talk too much about the front end, some things there. How we handle exceptions and some of the railway type stuff that you might have seen Scott Wlashin talk about. I'll also cover managing builds and how we do that with Fake, and then we'll have time for questions at the end. But I do like having people interrupt and asking questions throughout because I feel like it gives a better context to what we're talking about. So do feel free to stop me and ask questions as we go. So Tachyus is a company that does oil and gas software and hardware. The goal is to do better at measuring, analyzing, and producing oil from the ground and doing that in a more efficient manner. Most people don't know that for the most part, we only recover about 30% of oil out of the ground, and so one of the goals we have is to get that to the max we can. A lot of times the max is around like 60%. So there's obviously a lot of stuff left in the earth, and so that's part of the goal of what we're doing is to try to make that more efficient, and in addition, make it safer. I don't know if any of you have relatives that work in the oil industry. I live in Houston, Texas, so most of my family actually works in refineries or around the oil industry. So if you do have relatives in that industry, you probably know that there are a lot of situations and scenarios where there's a lot of safety issues and safety risks. So part of what we're trying to do is get more hardware in place to collect data rather than having people go out in the field and put themselves in danger. Tachyus is based in San Mateo, California as well. So that's a bit about Tachyus. The platforms we're using are ASP.NET Web API hosted in Azure. We're using Azure Web Sites to host it. We have an Angular JS-based single-page application providing information to office workers and an iOS application for workers in oil fields. So why F#? When we started, actually when I got involved in Tachyus was probably beginning of or end of last year, early part of this year. I was contacted by them asking if F# was ready for doing things on in Azure on the web, and obviously I'm biased. I've been doing some of this in my free time, trying to get people to adopt it for the last 4 or 5 years, and so of course I said yes. And some of the reasons why, and some of the things that we've proven to ourselves by using F# is that we generally write a lot less code, so it keeps things a lot simpler. We can get things done a lot faster by having less stuff to write. There's a really expressive syntax that's available, and through that there's also the safety provided by the type system in F#. We'll dive into a little bit more of that as we go, but just kind of at a high level, the types have actually saved us a number of times. We're using units of measure. We're using a number of sum types, so discriminated unions to show different pathways through the code or calculations and that sort of thing. And it's made it very easy for our software team to interact with our science team and make sure that we're doing the right stuff. And the code is therefore very easy to read, and even a lot of our domain subject matter experts have been able to kind of go through the code with us and make sure that we're able to produce the right stuff and the right results. It has full .NET compatibility, so most of you here already know a lot of these things, but this is one of the benefits is that we can build on something like Web API and don't have to build a complete web stack underneath us. And it's an active and strong community. It's small but growing, but it's been growing a lot since at least last November. I've noticed it seems like we've probably doubled or more in size, and there seems to be a lot of excitement around the F# language, and in the community itself. So as I said, we're going to start with data access. And I know this is called F# on the web, but you do have to start with data or get something from somewhere. So we'll start here. There's several options. We have Dmitry Morozov, who wrote the F# data SQL client on our team, so we're actually using his, and I'm going to show why that's pretty awesome. There are obviously a couple of other options in the box: DBML file and SQL data connection, which use link to SQL, and the EDMX file and SQL entity connection type providers that use Entity Framework. And there's also Ross McKinley's SQL provider, which is similar to the sort of notion of an ORM, but erases down to mostly ADO.NET code, which is similar to what the F# data SQL client does. And the F# data SQL client is probably best described by something Rob Connery said a while back when discussing Stack Overflow's ORM Dapper. SQL is the best DSL for working with data. I hope there's a few chuckles in the room. I know you all are. It's true, unfortunately, or fortunately, depending on how you look at it. It's very convenient to be able to write SQL. It's very convenient to be able to work directly in SQL Server or write SQL-based scripts to see if you can get the right data out. It's much simpler than trying to understand what's going on in SQL through the context of an ORM that you're writing in a different language. And while that's convenient, it's at least writing an ORM can be convenient. There are often a whole bunch of extra headaches that you give yourself by using it. So we're using it. I'm going to jump into Visual Studio to kind of show how we're using it. All right, so I've got a local instance of AdventureWorks, and you'll notice I'm going to take a step back and show what the project is that I'm looking at right now. So we've got this is an F# MVC5 web project. I am only looking in global asax.fs, and we don't put everything in global asax.fs, but for the most part, we try to put all related code in a module. So or a modular, sort of thing of related code, both data access, the manipulation of that data, and also the web API in a single file. We've been kind of extracting that out a little bit in some cases, but for the most part, everything is kind of like file per module in a sense. And so the whole like vertical silo is in one file, and most of those files are within like 100 lines. So it's actually nice and everything's together, and it makes a lot of sense when you start looking through what's going on. So I'm using the AdventureWorks database. I'm using this literal connection string, and it's looking in my web.config file in this case for a connection string name that matches AdventureWorks. And there's a couple different ways of interacting with a database using the F# SQL client type provider. There's the SQL programmability provider, in which case you create a new instance of your database, and the computer wants to work with me again and get IntelliSense on these things. And this actually gives you access to the functions and stored procedures. And in a moment, there we go. So now I can drill into these things and see what stored procedures, what functions I have available in my database. I can execute them directly using like an async execute or an execute. So whether I want to do it asynchronously or synchronously. So anything I store in my database, I can actually access using this. And it's just for programmability contexts or for constructs, so like functions and stored procedures. If I want to do something where I'm retrieving something ad hoc, writing a query, then there's the SQL command provider. And this is similar to what you might think of as a SQL command. You write the SQL, and I know this looks like spaghetti code. Let me go ahead and get rid of this little here. I've noticed that for some reason on this machine, I often get a lot of slowdown. I don't have this problem anywhere else, but in this machine, it takes forever to load the IntelliSense on here. Anyway, I'll move on. So SQL command provider, and we actually use this one a lot more than SQL programmability provider. It looks like spaghetti code, and you're probably kind of maybe shrieking in terror at seeing this here. The thing is that SQL is a programming language, and the nice thing about type providers, let me get my screen to catch up with me here. This is all type checked. I apologize for the delay in my computer. It seems like it Visual Studio is not. Oh, I hit F1. Sorry about that. All right, I'm back, I think. All right. So this is just a script. I don't get IntelliSense within the script itself. There is a possibility of using a SQL file, and in that, Visual Studio gives you IntelliSense, and so you can reference a SQL file instead of writing the SQL directly in here. And that can kind of feel a little nicer because then you just reference a file path instead of giving it some raw SQL. But the nice thing about this is if I change out the name of a field, I'm going to get some red squiggles as soon as it can resolve the compilation here. And so I can verify as I'm going through here writing some SQL that I'm actually writing valid SQL. It's going to verify that the joins that I'm trying to create are valid. It'll validate that the fields I'm referencing are valid. And it'll validate that the tables that I'm trying to reference are all valid. So if I go and say create this SQL inside of SQL Server Management Studio, verify that it runs correctly, and then copy and paste it in here, and then accidentally delete something or change something, I will get a compile time error in the SQL itself, and it will tell me that it can't find. At some point, it's going to break. If I can help it along by building. It's taking a while. I apologize for this. I don't know what's going on here. I wonder if it's because I still have this line here. This should turn red. This is a really cool demo, I promise. If you've already seen it, then you might not be as impressed, but I must be having some kind of issues with this thing. I've already run it, so I know that it works. I don't know why it's not responding as quickly as I would like. Anyway, I'll leave it right here for now. So what will happen when it turns red is it will give me a red squiggle and tell me that it can't find last name. So I'll know that which field is wrong. I'll be able to go and find it and fix it. It could be that it's in a join somewhere. In this case, I know it's not, so I'd be able to find and fix last name correctly. I'm surprised this is going so slow. Well, I guess you'll take my word on that one. I apologize that it's not the demo is not working out as well as I'd hoped. So the next piece of this is, so I've got this this type salespeople. So it's a command, and I knew it up just like I would a command. In this case, I could have named it salespeople command, and that might have made a little more sense. In this case, I'm saying new salespeople. It returns a command. It's a disposable, and then I can execute it. And this is wrapped in an async. There's an option to do just a synchronous execute. So if you don't want to asynchronously execute it, you can do that. The way that we use this is we do async executes, and then we pipe that through an async catch. And you notice this piece down here, which I'll get into a little bit later when I talk about exception handling, is similar and familiar probably if you've seen Scott Woloshyn talk about his railway-oriented programming. So what the async catch will do, if you're not familiar with it, is it will return a choice. And the first part of the choice 1 of 2, will give you back the result if it succeeds, and then the choice 2 of 2 will give you back the exception that would have occurred. And in this case, that will be coming through the database access. If another error occurs in here, obviously, we would need to have like a try and catch or a try with inside of the async block in order to catch something that errored out because, like, say, salespeople didn't exist or something like that. The other nice thing about this, and I'm going to jump in here to my test project, is that this type provider gives me, even though it's an erasing type provider, so it basically erases down to ADO.NET code at the bottom, it gives me types that I can work with in different projects. So this is a separate project, and I'm going to alias salespeople.salespeople.record. So it's salespeople.salespeople because the module is called salespeople, the type is called salespeople, and then the record is the generated type that you get
Hey
for an
Ryan,
instance. Yes.
your voice is coming over really, really soft all of a sudden.
Oh,
Like a
okay.
violin.
I'll
There
hold.
we go. Now we
Yeah.
can.
Sorry about that.
No
Were you able to
worries.
hear what I've been saying?
For the most part, it was just hard. Yeah, I
Okay.
would have stopped you a
I'll
lot
definitely.
though.
Yeah. I'll hold this up now.
Cool. Thank you.
Yes. Thanks for telling me and stopping me. Okay. So in the test project, I've got this record. This is the generated type. And what's nice about this is I can go across projects. I can create new instances of it. So in this test right here, I'm using unquote in case you're not familiar with this quotation use of testing. Um, I can actually create new instances. These are not disposable, so I don't have to do a new on here. But I can actually create new instances using that type and then do like a test verification. So I can actually run this test and show that it works. I'm hesitant to do so, but I'm about to jump back into slides anyway, so I'm going to go ahead and see if this will run. I'm so sorry that my computer seems to be lollygagging around here and not running very quickly. Okay, so I have to use Test Explorer. My goodness. It's like Hangouts is, I bet you anything, memory. So one thing I don't typically have Hangouts running while I'm doing coding, and sure enough, that's chewing up quite a bit. Okay. Anyway, this usually runs much, much faster, so I might just do the tests at the end. But I think this kind of demonstrates like, so here again, I've got this a function that there's my module salespeople. I have the function get salespeople passing in the parameters. We'll look at that function again real fast just so you can kind of see it. I mentioned that it has an async catch at the end, so we're doing the pattern match on choice 1 of 2 and choice 2 of 2. So here I'm taking in top in, region name, and sales more than, and then passing those through. So this async execute method that's generated looks and finds all these parameters that I've passed in here, and will generate the additional parameters for the async execute method based on the parameters in MySQL. So top in is up here in the top statement up at the top. So I get a really nice experience for building out, for executing the commands, for building out types. It's pretty slick. And again, the choice 1 of 2, so if it's successful, I get the people, and if I don't, if I just get an exception, I'm returning an empty array. I'm running this synchronously, and I'm expecting there to be 3 of these. And I kind of cheated and verified that this would be the case in this specific query. And then I also have, actually, because I said there are 3, so there should always be 3. And so then I also found out what they were and then made instances of each and could verify that those are the exact instances that I should see. All right, are there any questions on this? I'm going to go back in here and break the SQL just so that hopefully by the time we come back to the code, you can see that there is actually something wrong here. And there are red squiggles dilating our eyes. Any questions? Nope. All right, I want to hop back into the
Nope,
slides.
I don't think so.
Okay.
If I leave this unmuted, let me know if you can hear yourself still. We moved the speaker away a bit.
Okay, I think I can do it in such a way that I don't hear myself as bad.
That way you get a little bit more interaction instead of just muted.
Yeah, we've all left.
All the chuckles and stuff probably are
Yes.
helpful.
Yeah, that would be helpful to hear. All right, so now we're going to get to the heart of the talk and probably why you came. F# on web. And I liked this little image. We'll sit here in step 2. The reason that I like this image is that if you've used a lot of the ASP.NET frameworks, you'll probably recognize that there's like this section over here where you know where you're doing your data access and some of that stuff, and then you've got your client code that's consuming your APIs and doing some, JavaScript-based code. A piece of like routing and some other pieces within ASP.NET are not always easy to follow or easy to understand. Some of that's the parameter binding, some of that's the model binding, some of that's the routing itself. And sometimes it works, and sometimes it doesn't, and in many cases it has some sort of spell to make it work. So simplifying this a little bit, ultimately when you get on the web, you're looking at a function that takes a request message and returns a response message. This is the simplest way you can think of web applications, and it's very simple. And this works for both client and web story. And the component parts of HTTP are built up of request and response. So there's like the methods, URIs, text code, so all the kind of the first line pieces of the messages. There are headers, and these can be things that provide information to the client, to the server. It could be something related to the type of request that's being made. There's different types of headers, like general request, response, and then content-specific headers. And then lastly, there's also the notion of resources. And a resource, according to RFC 2396, is anything that has identity. And identity in HTTP is defined by a URI. So a resource, and this kind of gets into like just the notion of routing, and the library that I'm going to mention here in a moment focuses on HTTP resources as opposed to just random sets of services or posts, sort of things on different URLs. So the notion of a resource is like, say you have like an /item/1, and that defines some thing. A get, that thing should give you the thing. A post should do something against that thing. It's not necessarily defined what that's going to be, but that means something is going to happen. And it will change state. There's just kind of assumptions that something somewhere will happen, and you want the response to give you some information about what happened. A put means I'm just going to replace whatever's there or create something new in that location. I already have the URL that I want. I'm going to shove something in that spot. Delete is similar. It takes that thing away. And then options will list what HTTP methods are available on that thing. And those could be either the standard set, it could be extensions. There's a whole lot of, again, the main notion of a resource, this uniform interface is available against each single identity. It may work slightly differently, but for the most part, the methods work against that thing in a similar way all the time. Contrasting that with the HTTP service is that it's just kind of a random assortment of stuff. There's not really a really understandable way of how you work with those things, or whether there are even things at all. It could just be that you're message passing, and there's nothing really wrong with that, except that it doesn't really model HTTP the way that HTTP works. And so where does F# shine in all this stuff? Well, serving functional web APIs, and that can mean both working web APIs and also building up web APIs in a functional manner, and also in consuming HTTP with pattern matching, and we'll look at both of these things. We'll look at the latter in the context of testing only in this case, but I'll discuss a few things that I'd like to try to kind of flesh out more in the future as I'm progressing through some different ideas that I have here. So the library that I created to get rid of some of the magic in the middle is called Frank. And this is an F# DSL using system.net.http. There's another one that I'm actually working with the creators of called HyperF that does some things that are very similar and does some other things that are actually quite unique to that library. Frank is, for the most part, kind of a composition DSL. It's got a lot of combinators to help you kind of construct up the messages, tear apart the messages, and do things to kind of mount resources within a web serving application. So it has things to do like composition of headers, position of HTTP, and that like you can define functions against specific types within something that takes a request and pulls some pieces of the request off to get the parameters that are needed for that function. can do things to detect media types and apply the correct serialization or formatting against the result of your, your domain function, if you will, and then generate that into a response body, again, appending additional headers and whatnot as you need. And again, it's modeled on the idea of resources, HTTP resources in particular. But the general idea of this whole thing is that it's really kind of define your own conventions. And for a while, I just deployed Frank as a source-only NuGet package because I figured you want to go take a look at it and then delete half the stuff that I put in there or replace it with your own stuff. And it's really more of a, at least the way that I've designed it or tried to think of it, was more of a guide. But I've found that several people actually like the opinions that I put in there, so I just started deploying it as just a regular assembly, which I'm kind of debating whether to do both again or what. But it's at least an idea of how things can be built. And the simplest HTTP application in Frank is taking into account the fact that you're actually going over I/O, and in particular, since we're using system.net.http, which is task-based, the simplest thing is an HTTP request message that returns an HTTP response message asynchronously. So basically the same thing, but with the acknowledgement that there is, in fact, some async work going on. So to define a method handler in Frank, it's just a simple function. In this case, we're doing like an echo resource. So this thing is going to take whatever it gets and return back the exact same information. So again, because we're using system.net.http, reading a string out of the content is an asynchronous task. And this is actually a little bit out of date. It's now just using the read as string async that's built in. And then I have some extensions against the async builder that let it receive that task as an async and kind of just compose it in here. But anyway, you get the idea. And then you can return the response. And in this case, I'm just showing the kind of standard system.net.http stuff. Again, I've got some other combinators, but I figured to keep it simple, I would just stick to the system.net.http stuff. And then I did a bad thing here and used get. I should be mounting echo as a post, obviously, because gets don't have a body, or at least in the sense of a web API, I think it actually errors if it gets a body in the get request. So pretend that that's a post. So then going to the resource idea, to define a resource, we've got a couple different ways of doing this, but in this case, I'm showing the route function, and it takes a string that is the URL template, and it always starts with a single slash. So this is basically the root of your API, and then it takes either you can do a route resource, which takes a list of these handlers, or you can pass in this sort of chainable function here, and this less than pipe greater than stands for or. So this is saying at the route slash the root of the site, I want to serve get hello world. So whenever I get a get request, I'm gonna do hello world, and when I get a post request, I'm gonna do echo. So it's basically saying I serve get or post, and these are the handlers that I invoke whenever those two HTTP methods come in. Route also does the basic options sort of thing. So it builds in options for you and says, so if anybody calls this with options, they would actually get back that it serves get and post as the response. And then looking above, again, it's just these are hello world and echo. The implementation is hidden because in this sense, it's not really important to see that. And then defining an application, the way that this is built, it lets you kind of push this in amongst existing web API controllers. So if you already have like an F# web API project and you want to add in a Frank-based web API, you can just you can call register, pass in the list, and then pass that to the config, and this can live right alongside existing more like classic web API controllers. So like in this case, we've got the to-do item or to-do list resource, which has like the to-do list, and then a to-do item, which would be like the /item/1 or placeholder, whatever the ID might be. And this would take like a get or a put or whatever else. So F# and ASP.NET. F# works out of the box and this is, let's see, works out of the box. Yes, so you can create a new web project in C# and then add an F# library, move all the, rewrite all the stuff in F# in the library. And this is actually not a bad idea, and we've actually moved to this recently, just to try to get all the HTML and JavaScript and all that stuff out, as well as to be able to use tools like Web Essentials. There's a lot of problems in the F# project system. So certain Visual Studio tools and certain even Azure tools don't work as well with an F# only project. I did help Dan Moll create the F# MVC5 project template, and we were actually using that for quite some time, and it worked really well for us for most cases. There's just certain things that we wanted to start using that, based on feedback from the Web Essentials team and the F# team, we found out that like the C# plus F# projects were a little bit better fit for what we needed to do. And then obviously Frank, there's HyperF, there's a whole bunch of other projects that I'll throw out there in a little while at the end, whenever I'm kind of talking about like some of the work that's ongoing in the web space for F#. All right, and so we're going to bounce back into Visual Studio. Hopefully Visual Studio will play. Here we go. We have a red squiggle, finally. And you probably can't see this super well, but if you look towards the bottom of my screen, you'll see the type provider, F# data, SQL command provider, reported an error, invalid column name, first NAM. The batch could not be analyzed because of compile errors. So I'll fix this real fast. And I'll scroll down and we can look at the web API bits that I've got set up in here. Before I look too far at like what I'm currently doing, I'm going to kind of just discuss like what a web API project looks like in general for those who may not know. So this is the F# MVC5 web project. This is just a default project. F# Web 1 is the first one that I built out of this. And it comes with some content. It comes with some scripts already in here. So it's got like kind of a minimal working application already in here. And it's a car controller and car model type thing. So a web API controller in F# looks like, oh, this isn't the controllers, that's just a model. The web API controller in F# looks like this, or can look like this. So in a web API, you would say, I'm going to create a type. It inherits from API controller. There we go. Go away pop-up. So I'm creating a type. It's called controller. And web API, you have to name it controller. It is not an option. It is a requirement. You can change a lot of the configuration of web API, and so you can get rid of that requirement. But there's a lot of plumbing you can actually replace in here. But by default, it does require it to be named controller. It has to inherit or implement iHTTP controller, but there's so much stuff going on inside of there that just inheriting API controller is sort of almost necessary. In here, I've got like a private list of values. So we've already got like a set of cars that are available to load. And then when I'm doing my HTTP methods, you start your controller method name with the HTTP method, and you can put whatever you want after the fact. It's just if you want the kind of the reflection-based determination of like what HTTP method it should serve this function at. So like here I'm using get. It will by reflection look and see, hey, do you have a get method defined in this controller? Yes. Okay, I'll route that as a get. And then I don't have to pass anything in here about like the request or return anything about the response. It's doing some magic to say I'm not using anything out of the request, and I'm going to return this car array asynchronously as a HTTP response message using status code 200. So there's a whole lot of stuff that's going on to make this work under the hood. This isn't like super important, but doing some performance testing on this, I noticed that like a web API, like this controller, in fact, serves content within like 300 milliseconds to 500 milliseconds. A similar thing using the Frank library takes like 30 to 60 or 70 milliseconds. So like there's a lot of overhead in terms of the reflection and some other stuff. Granted, most of the time we're not doing something this simple, and so like the I/O and everything else is part of the problem. But it's just kind of interesting to note that there's so much going on This is fairly convenient, but it's just something to be aware of when you're dealing with some of the ASP.NET libraries. They're definitely fun to use and fun to work with, but there's a lot of kind of magic going on. So taking that into account and scrolling down a little bit, I'll show you kind of how we're breaking up a lot of our Web API components here. So we have our get salespeople function that's getting our data. This result is just kind of showing like what this async catch is returning. I'm not actually using this anywhere. And in fact, we are using something similar to what Mauricio Scheffer did in his Fleece library, which is a JSON serialization library, but it's like a very explicit way of doing it, where he uses active patterns and functions to basically wrap choice 1 of 2 and choice 2 of 2 to make them look like success and failure. So it looks a lot like this in the way that we're using it. In the sample code below, I'm using choice 1 of 2 and choice 2 of 2 just because it was easier to do and it's out of the box. I didn't have to add any additional helper functions or libraries or anything to do that. All right, so going through, I'm going to kind of go through in the way that this is built, as opposed to maybe what might make more sense of starting from the top and going down. I'll kind of go through, like, list what the functions are, what their purpose is, and then I'll roll back up to show like more detail. So validate is validating that a person record is valid. So this is looking for, it gets a sequence of people, and then checks to see that the length is, if the length is greater than 5, it says the result set is too large. It's just like an arbitrarily useless validation, but it's one just to kind of show or prove the example. So here I'm returning a choice 2 of 2. Otherwise, I'm returning a choice 1 of 2 to indicate success. So we're kind of pipelining these choices throughout our code. The next one up here, toResponse, takes a request message, and then based on what comes out of the choice 1 of 2 or choice 2 of 2, it either creates a response of the people, or it creates an error response using the exception message and says that's a bad request. We also have this helper function that's a bind. If you've done anything with computation expressions or are familiar with monads, this will look familiar. Understanding that stuff is not at all necessary. As you can see, a bind is simply taking some value like t and then creating basically doing like a map on t and returning it as a choice. So here I'm going to get in some value. I'm using the function syntax. This can also be a match. I'll do this for sake of completeness. I've also used function above. So like function basically indicates that there is another parameter coming in. But instead of explicitly declaring that parameter, you can just use the pattern matching aspects of F# to indicate that that parameter needs to be matched. In this case, I have to actually add value as another piece here. So I've got a transformation function, and I've got a value. Value in this case is in fact a choice. So I'm going to take the value out of the choice, in this case res, call F on it, and that will give me the next choice. If it's already a choice 2 of 2, I just return the choice 2 of 2. So I'm just kind of saying, if it's already errored out, continue, just give me back the error. And if not, do this mapping function and give me back a choice. But take out the value first and then and pipe it through that way. All right, and then we get to the salespeople handler. And again, if you have any questions, please feel free to unmute and ask. I'm kind of speeding through here a little bit, but I'm just going to assume that you've probably seen some of these things or somewhat familiar with them. And if once we get to the end, you still have some questions, we can definitely address those.
Okay, we do have a question here.
So
okay, good.
Array.parallel.math, is your list large enough to take advantage of the parallelism? Or?
No, it's not. No, I just put this in here as one example to kind of like additional F# stuff that you can take advantage of. Yeah, in this case, the query name value parameters should be 3. So mapping these in parallel is probably not worth the effort. That's a good question. So you'll notice salespeople handler, and you could actually do this without. So let's look at salespeople handler. So the signature of salespeople handler is an HTTP request message to an async HTTP response message. So this is the signature I showed earlier. This maps pretty well to the web API syntax. So even if you didn't want to use something like Frank to route these things, you could, and we do in many cases, still have a lot of handlers that are defined like this, where they take a request message, return a response message asynchronously, and then we map that into a web API controller, and like do a async start task or start as task to return it back as a task that web API expects. So this isn't like a library specific thing. This is something you can use pretty easily within web API as it is. In this case, I'm actually doing getting the request message. None of the query string parameters, I'm assuming, are required. They're all optional. And so I could be just providing some defaults if I wanted to. And so I'm tearing the request messages query string parameters apart, and then getting back the values if they're available, as well as you can see I'm mapping these things into the types that I'm expecting to be able to need to pass into my data access layer. So in this case, I'm saying, try find against the query string where the key is top in, and then map the value in that pair as a long in int64. In the case of region, I'm just doing, give me the second value, so give me the value of that pair, and then lastly, creating a decimal for the sales. So these are all the values I'm going to pass into my data access function. But first, because these are still options, I'm doing a match inside of my async block here to say top in, region, and sales. If they're all provided, then call the data access layer, get the result, pipe it into validate. So again, result is going to be a choice. I'm piping that into validate. So this operator that I defined above is bind, and I used an operator like this just so I could kind of keep the same sort of flow that I have with like the forward pipe operator. And so in a lot of cases we do this attack case, we have a lot of these things going through. We do a lot of pipelining, and so it helps to have operators that look similar, work similar, so you can just kind of pipe through the result from one to the next. So this is getting the result from the database, it's validating the result, and then it creates a response passing in the request. And one thing about system.net.http and web API in general is that to do correct rendering of results, you need to actually attach the request to the response. So using the extension request.createResponse, or creating a new HTTP response message and setting the request message property to the request is usually fairly required. There are certain scenarios where that's not that important, but in many cases it's best just to go ahead and do so. That's why this request is being piped again to the toResponse function. You would think at this point we've already got everything off that we need, but again, part of this is just part of the serialization logic within Web API that I am in fact using here. I could manually serialize the result. Maybe like after validate, I would then transform it into a stream or a byte array or a string or something like that, and then I probably wouldn't need the request at all. But in this case, I'm just going ahead and using it. I'm using the built-in JSON.NET serialization for JSON. And again, that's just part of how Web API works. I'm not going to get into the guts of that, but if anybody has any questions, I'll be happy to talk more about that. And then again, if the match doesn't have, or if not all values are provided, I am saying, okay, we're just going to do a bad request in this case. The idea here is that I might actually want to provide some defaults, and so I could do other pattern matches and say, like, I might take, by default, I want to get the top 5, some region or something else. So like the idea here is the pattern match could actually be more complete and have a bunch of different options based on which query parameters were provided. All right, so once I have my handler, and I'm only doing one handler in this case just to kind of keep the talk to at least a reasonable time frame. I'm creating a resource, and I'm using route for this. Again, this is going to be routed at /salespeople. And then I'm using the backward pipe instead of using parentheses. You can use either one to say mount salespeople handler on the get HTTP method at the /salespeople URL. And that's pretty much it for Frank. I'll show where it's getting mounted up for in the HTTP configuration. It's up here. So this HTTP route is a definition that's needed to correctly route using the Web API built-in routing. So what we just did is basically do like kind of a mini version of that routing. It's all very explicit. Here I'm registering that resource with the HTTP configuration. It's the same configuration used to do everything else. The other stuff is using HTTP attribute routes or using just the map HTTP route that's another part of like the older default implementation of routing for Web API. And then I've set some other things here for serialization so that my JSON is camel cased, and also that we're using the XML serializer because I didn't decorate the car model type with the data contract attributes. I think there's a few other settings down here that are all part of just like the default template. So if you basically went and did like a default MVC5 template, you'd see most of the code that's in here. Yeah, so here's at the very end is the place where like the global configuration. This is just again part of Web API when you're running on top of ASP.NET. And this is just the built-in stuff out of the box that comes with this template. All right, so now that we've been talking about all that stuff, I'm going to actually run this and show you that it does in fact work. If it didn't, that would also be quite unfortunate. And hopefully it will not see that I changed anything, because ultimately I have not really changed anything. Man, Chrome is really eating my lunch today. Maybe this is a sign that I need to get a new machine. Well, while we're waiting on this thing to run, do you have any questions about what I'm saying?
So the let salespeople resource where you specify the route right there, and the salespeople can use like the get for that. Is that like a different way of assigning the route, as opposed to the other one that we looked like that you were saying used reflection for the getter?
Yeah, so this is a function that actually takes the handler function, and then it gives you back an HTTP method list with a function that takes an HTTP request message and returns an option of the result of this function, which is, again, going to be an HTTP response message. So it's an option because you may not have all the HTTP methods mapped. And so if it does get back a none, then it returns back I think it's a 405 method not found HTTP status code.
Okay.
Yeah, so this is, I don't think that option is built into Web API by default.
No, I don't think it is.
Not every controller is meant to, it's not meant to be resource oriented. It looks kind of resource oriented when you build a controller and you keep to like a single get, put, post, delete or something like that in the controller. But it's not really built around the concept of resources. It just looks similar to it.
Question also. I was just wondering, like, what happens if the try find doesn't actually find anything? Is it like an exception, or how are exceptions handled generally in this flow?
Did you hear that?
Sorry, I didn't get the first part of it.
Can you come up here?
Oh, in part of the flow you had the array try find. What happens if it doesn't find something, and also does it produce an exception, and in general how are exceptions handled in this flow?
Oh yeah, so it can produce an exception from the database, and I could actually wrap the call in the database piece here or anywhere else with a try with, And then similar to what I'm doing in validate, return back to choice. So I'm basically doing like a forward-only exception flow. Exceptions don't get like thrown back out. Everything should be captured and pushed down to where at the very end you make a decision as to whether you want to handle it as an exception or handle it as a result. Does that make sense?
And so where is that happening? I mean, what's the final decision right now in the flow?
So that is happening in toResponse. When you pass the HTTP request message in, it says, do I have a choice 1 of 2? If so, create a response with that result. And then if not, I've got a choice 2 of 2 with an exception, so I want to create an error response with that exception. That's a bad request in this case. I could put internal server error, I could put a bunch of different things. I just picked bad request as a I think in this case, because it could, let's see, I'm trying to remember why I used bad request. I think I just picked it at random because I don't, this is more of an example. It's not a really great, well-built application. It's been more of an illustration of how we're doing things. Like in the case of, like for a real example of what we're doing at Tachyus, we have one where it has like 4 or 5, I can't remember exactly. It's got 4 or 5 different exception path possibilities. And so one is it could be trying to insert a duplicate record. It could be validation at one level. So like at different levels of it, it could be throwing back different like different errors. And in the case of like a failed validation, we send in a bad request. In the case of a duplicate, we do like a HTTP 409 conflict. And then if like an error gets all like happens at like the very end when we're trying to wrap everything up, then we do a 500 internal server error. And so we can kind of handle the exceptions at different layers and kind of send that through. And then at the very end, pass the exception through. And like instead of doing it like this, we're actually detecting what the exception type is, and then picking the status code based on the type of exception. So this, again, it's not really a wonderful example. I could have done a little bit better job of showing like how that works. Like, I think in this case you could actually even on the type here.
We have another question.
Something being a different exception.
Do you do any logging?
Yes.
Do you do any logging? I noticed you've got where you log to your log file, so you can go back onto the server and say what happened yesterday. You have any?
Yeah, we're doing a message handler for that, and this is part of Web API. Web API has a thing called an HTTP message handler. Pretty much everything in Web API is sort of like a message handler, even a controller, except that a controller just has a lot of the extra, like a sugar to try to make it simpler to write. I don't have an example of a logger here, but the way we're doing our logging is kind of on the outside. We wrap requests coming in and responses going out, and we log the request coming in, the response going out, and the time that it took to handle that request, and stick that into table storage in Azure.
Cool.
Yeah, I don't have an example of that here. I actually do have a blog post on that topic, and I don't know if I used the logging for that or not. My goodness, this thing is so slow today. I'm so sorry that the response time was so slow. I think this thing finally built. I'm trying to run it while I'm looking for my blog post. My blog is called wizardsmart.net. It wasn't originally mine, and the name is not mine. But I'm now stuck with it. One of these days, something will finish. Yeah, so build succeeded. I don't know what's going on. let's move on to the slides again. And we'll come back and see what turns up first. All right, so we went through the web stuff, F# and exceptions. We kind of just talked about that part. If you want more information, a good slide deck. He's got an excellent article on railway-oriented programming, and he's also got a fantastic video on Vimeo from the NDC conference. I don't have a link to that here. I can pass that along to James to post into, or I can even post it into the meetup page for this event. Is everybody still there?
Yep, we're here.
All right.
Yeah, I'll go ahead and gather all of those links from your slide, and we'll get them up on the meetup.
Okay, excellent. And this whole project is actually under my GitHub account as F#Web1. It's a very creative name. I figured nobody would look at it, so I could pretend like this is a new talk every time I give it. But if you want to go find it and find the code and run it locally and see that it actually does work, and it runs quite quickly, in fact, then you can go get it and build it yourself, try some different things out. Before I move on to the build piece, does anybody have any more questions on the railway-oriented programming? Scott Washington does a fantastic job discussing it, so you'd probably learn a lot more about looking at that. Happy to answer any more things or questions related to it if you want.
Nope, I think we're good right now.
Okay. Yeah, the main concept is just you push everything forward as opposed to having things kind of bounce back and forth the way exceptions fly. So we're using Fake, which is a F# make Stefan Fortman as our build tool. And Scott reviewed it on his blog not long ago and said that Fake is a domain-specific language that you can use without knowing F#, but if and when you outgrow it, you can keep heading down the F# road. In all cases, you've got all of .NET at your command. And this recently came in very handy as I needed to do some XML config transformations. You couldn't find a really good tool. I don't know if anybody noticed, but Slow Cheetah, which is a fairly good tool that I've used in the past, is going into like maintenance mode. And so that doesn't mean it's necessarily bad, but I was like, I don't really want to add another library. And so I just popped in system XML and did some transformations on the config files, and everything worked really well. And it was just because I'm already in F#. It's simple enough to load those files, do the transformation during the build, and then everything's good. So that's been super helpful. Let me open that file up and just show who is awesome. IIS Express failed too. Man. All right, who's familiar with Fake? I'm assuming everyone has at least heard of it. Is anybody not familiar with it?
Yeah, we have a few people who've not heard of it.
Yeah.
Oh my. This is tragic in terms of how slow this is going. I am still here. I'm just waiting. So sorry that this is taking so long. Okay, so I'm going to open up the build script. Fantastic. All right, so Fake has these things called targets. If you've ever used something like Rake or Pasaki or some of the other, so you define a target, you give it a function is basically a callback whenever this thing is run. This is in fact a unit. Just usually use an underscore because it doesn't matter what it is, and typing 2 characters instead of 1 is silly. So underscore is used. There are no parameters in any of these things. But there's some pretty cool tasks built in. So like here I can create an assembly info file for F#, and there's another one for create C# assembly info. You can give it a file name and then give it the different aspects of the project that you want to fill in, or attributes of the project. There's a restore packages built-in function to do NuGet package restoration. And there are other variations of this function. So if you want to do like specific packages config files, you don't have to do like this one will do a restoration of every single config file in the directory tree. So say you have like a big solution and you want to do like separate builds for separate pieces of your solution, you can do specific restorations on config files for those different builds. There's one to do clean directories, which will erase the entire directory and then create the directory afresh. So like here, the bin folder, I'm doing it at a top level, and so I clean it out and recreate it each time I do a build. There's a lot of MS build helpers, and there's recently been one that does like that uses the F# compiler service to do a build as well. So you can skip MS build to the F# compiler service and have it generate your assemblies for you. There's like InUnit, XUnit, and a few others, and then those can take parameters, and then you can just use the defaults that come with it to kind of tailor how you want to structure it, where you want to put the results of the tests, that sort of stuff. And then at the very end, you define like the dependencies of each one using this little mini DSL using arrows. And there's other ways of doing this where you can actually put like a question mark and return a Boolean saying when it should or shouldn't, or whether it should or shouldn't run in this case. So in this case, it'll be saying, I'm always going to run clean. I may run restore packages. In this case, it's true. So this is sort of nonsensical to do this, but it exemplifies the point that you can customize how this works. And then it will run assembly info. And these will all run in this order, kind of backwards. So if you run all, it will run from clean all the way through all. If you run build, it will do clean all the way through build, but not run tests or all. So it's a pretty handy little language because this is just an F#X or an FSX file. You can define any number of functions. It doesn't have to be within targets. I don't see anything that I've done in here that looks like that, but yeah, you can define any functions or variables or whatever else you want to use in your targets outside and reuse them across. You can add your own libraries. They don't have to be fake related or tied into fake directly. You can have like just a library lying around, or even an FSX file lying around that you want to include, and then use that functionality in your build script. So it's pretty nice. So since this thing claims to be running, it's sort of running. It has not finished loading yet. It's going to show you the results of all of this this waiting around, but it looks like it's still taking a little bit of time. So instead, we will hop over. There's a lot more. Before we move on to this page, does anybody have any questions about fake?
Nope, no questions.
Okay, that tool has been fantastic for us, and we're using it in context with AppVeyor, which is a cloud-hosted CI tool, and like the combination has just been amazing. It gives us some really good outputs. Yeah, it's been quite nice. So this focused on like an API layer. There are two projects, WebSharper and FunScript, that do F# to JavaScript compilation. We are currently evaluating some other things besides using raw JavaScript, and WebSharper is one of those tools that we're looking at, and may be moving to very soon. We'll have to see. There's another project that I created called Vega Hub, which shows use of OWIN and SignalR with F#, and it actually interacts with your F# interactive window. just more of a play thing for doing like data science, interactive charting type stuff. So it also a cool demo of what you can do with F# on the web. There is a group of people working on this or having discussions about the F# web stack. And I have OWIN-based tools, but it's not really strictly OWIN-based. And OWIN is the open web interface for .NET that I'm involved with as well. It's meant to be like an abstraction layer between servers and runtime. So theoretically, you could create your own mini server and then run your web app on top of it if both are doing OWIN-related things. Most of the servers that were open source at one point have all kind of seemed to have died off. There's a few that are available, but the framework itself has become part of ASP.NET, so you'll notice OWIN-related packages from Microsoft, and as well as some other third-party groups. And the F# web stack is currently working on like several different projects. So Frank is one of those, HyperF I mentioned earlier, and then there's two other ones, Diffrig and Taliesin, are both really more OWIN-related projects. Taliesin is actually in the Frank organization, and it's kind of like a routing mechanism that lets you do more of a static typing route mechanism as opposed to the strings that I was showing earlier. So you get a little bit better guarantee that what you've got is going to, at compile time, check out. Diffrig is really just more of a minimal OWIN F# API that other people can build on. And so resources, I didn't actually show my testing stuff. Like skipped all the way past it. I'm gonna hop back over here real fast. I'm gonna check the web page one more time to see if it loaded finally. Dang it. It did not. Okay, I'm gonna kill that. Sorry, I could not show that. My machine is just not working with me today. It does run. The example is so trivial that it's almost not exciting. It's always fun to have something run, and in this case, it did not, which is sad. Okay, so here's our data access stuff that we showed earlier. I mentioned something about active patterns earlier and using it as like a client consumption type of thing. So active patterns, if you're not familiar with them, let you define pattern matching on non-matchable structures. So in this case, I'm using HTTP response messages as my the .NET object that I'm going to define matching capability for. And the ones that I've defined are JSON, OK, bad request, not found. I have another one like internal server error. Nope, just those. So what these are doing is it's going to take a parameterized or just the parameter of a response, check some things on it, like this OK says, does the status code equal OK? If so, then return some, and I'm actually deconstructing the response message into its headers and content. In the case of JSON, I'm going a little further. If it's OK and the media type is application JSON, then I want to read it as a JToken, which is a Newtonsoft JSON.link type, and return the headers and the content, which is going to be it's actually an asynchronous content, so an asynchronous JToken. So in all cases, I have to read these asynchronously. The same thing for bad request not found. It's just checking the status codes on those. So down here, where and this is also kind of a cool feature about Web API. I'm actually going to create a configuration. I'm going to create an in-memory server based on that configuration, and then build a client against that server. So HTTP client can be used without passing anything in directly against like a real URL. In this case, if you do pass in an HTTP server or any other HTTP message handler, you can actually run this all in memory, and it's all chained together directly. So this client is actually going, even though I have a full URL down here, it doesn't actually care about the localhost 48.2.13. It's just going to care about the actual path in here that's defined on that server. So then when I call client send async and pass in my request and get back my response, I'm then going to pass it through this pattern matching. And in this case, I'm expecting it to be JSON with that content. I'm going to await the task, get the JSON content back out, and then I've got tests in here to verify that the status code was in fact OK. and that the JSON that I get back is assignable from a JArray. So I'm not doing the full extent of what I did above. It's more just exemplary. And this is sort of a silly, trivial example. Some really cool things that could be done with the pattern matching aspects are doing things like there's a client-side construct that you could say, you can send a request to a server and say expect 100, HTTP status code 100, meaning continue. So you could actually construct a bunch of patterns and then use those active patterns to construct like a flow of expected request response interactions in a series or something like that. So there's actually some pretty cool stuff that can be done here with active patterns. Are there any questions about this?
Nope.
Okay. Cool. If you're not familiar with them, there's the F# Software Foundation at fsharp.org. The community for F#, which I help run at c4fsharp.net. And you can find out about various user groups. There's a lot of videos. There's also several dojos that you can use for your user groups. I think James probably knows about some of those and has had Matthias up there in the past. So I know you already know about some of those things. If you're not already following Sergey Tikhon's F# Weekly, I recommend that one. Scott Woloshin's F# for Fun and Profit is always quite fun and has a lot of really good material in there. And then Real World Functional Programming on MSDN has a lot of the chapters from Tomas Petrocek's old book. I guess I can call it old now. It's like 5 years old now. It's still quite relevant. It's just one of the older, but still very, very good books on functional programming and .NET. All right, so I'll open it up for general questions. And apologize one last time for the fact that this didn't quite work out as well as I hoped in terms of getting things done.
Do you have this example? I'll run somewhere.
It's unmuted.
It's okay.
You have this example up on your GitHub repo, right?
Yes, I do. Yes, it's F# Web 1.
Yeah, I'll go ahead and add that
And,
link in the meetup notes.
Okay. And my account is Painted Glass, which is how you can find me on Twitter as well.
And are you using in your production web applications like a SQL like a type provider? And if so, how has the performance been?
Yes, we are, and the performance is fantastic. We're using the F# Data Super Client type provider. And Dmitry Morozov, the guy who's working with us and also helped write it, did a comparison with the other like micro ORMs and other ORMs that Dapper maintains, and it runs right on par with the Dapper library, which is one of the, I think it's the top contender right after ADO.NET, like in the raw. So it's extremely fast in terms of overhead, and it does so by erasing all the types that are in there. So it basically does exactly what Dapper does, except it's not doing reflection.emit at runtime. It's doing everything at compile time.
So the penalty for establishing the type is, basically done entirely at compile time in terms of contacting the database and checking the schema, or is that done every time it executes?
That's done at compile time. Everything is built into the assembly.
Yeah, it's kind of before. That's one of the cool things about the type providers. It's pre-compilation.
Yeah, because it has to give you access to all that IntelliSense before you can compile it.
Right.
Does that? So we saw it was slowing down a little bit today. If you have 100 tables or something, that's still going to be reasonable, or
Yeah, it's actually quite fast. My work machine, I was working on it today, and I've done a little bit of this, and it responds very, very quickly. I'm really surprised that this has not been working out very well. I have noticed that my SQL server on this machine seems to also have problems, so I'm betting that it's probably something to do with SQL. And in this case, a lot of this was all running much faster earlier, and I think Chrome is like just clogging up my memory, so I think that's why everything is running so slow right now. But in general, this runs really, really quickly. It's fast enough, in fact, that you haven't accepted. So like the first time you run it, you have to accept the type provider in the IDE. and it runs fast enough that the first time you try to build it, it will start throwing up like exceptions everywhere because you haven't accepted the type provider to run inside of Visual Studio yet. So everything breaks initially because it's already breaking before you even get through building the first time.
Yeah, in SQL Server there was a setting on how much memory it will use for cache and stuff. I don't know if you set that on your box.
Yeah, I probably need to do that.
You right-click on the server instance and there's a max memory, and literally SQL Server, a lot of people don't know this, but particularly for developers, if you're using SQL and you ever query a large table or something, it will use all that memory. And it has no idea about any other application on the box. It will really hammer your box. And it also, if you ever install 2 instances of SQL Server on the same box, you really, once your database grows large enough, again, they'll fight with each other and they will kill each other's performance. But it's very easy. The very nice thing about it, one of the nice things about the setting is you can actually change it at runtime. You don't even have to reboot the SQL Server. So you can actually change that. It may take a few seconds to drop the memory down, but it will. Because again, SQL Server caches a ton of stuff if you let it, and it will kill things.
And have you found any cases, well, I guess what I'm wondering is that for your queries, are you doing everything basically using SQL, or have you found cases where it's actually faster to query a larger data set and to do some kind of like grouping or filtering just using F#?
We're doing both. It really depends on the scenario. There's a lot of things that we've got, like our science team building algorithms on, and so we'll pull a lot of data and pipe it through the algorithms that they're building. Some of those things are things that like we've been doing in terms of just pivoting. So we're using the SQL, the Azure SQL database, which doesn't have pivot. So anytime we have like say a report we want to pivot on, like say we want to, like in this case, like say we wanted to pivot everything on like the business entity by business entity ID. You can't pivot in Azure SQL database, so we have to do that within F# itself. And generally speaking, it's fairly quick, but there's definitely a lot of slowdown because we're doing so much on the so much aggregation and even the pivot piece on the F# side, because it's mostly I/O. The query itself usually is fairly large. We haven't seen as huge of a hit just on the processing of it, but there's certainly a little bit of a hit there.
Data analysis libraries. What libraries are you using for your like heavy lifting on data analysis?
I don't know that we are using anything. Everything has been just straight up F# for the moment.
Another question regarding the SQL. So you said that you can do it inline, or you can actually put it in SQL files.
Yep.
Which do you end up doing more often?
I tend to put it in here, like inline. And we have some SQL files. There's a. Sorry, go ahead.
Oh, I was gonna ask also if you do it in a file, do you have the same compile time checking of your SQL code if you had it in a separate file?
Yes, you do. And it's actually the SQL piece is actually quite nice because Visual Studio will give you IntelliSense on the SQL file. The main problem, and this has actually been fixed recently, we probably will be moving more to SQL files in the near future. There's a feature in here called resolution folder. Let's see if I can get it to pop up. Previously resolution folder had meant some like different things, and it's kind of confusing. And that now resolution folder means my SQL files will be found in this folder, and so you can put it like at the root. And whenever you want to use so I guess it helps to understand the problem here. If you have a SQL file and it's in one project, and you want to use the type that's generated in another project, like I showed with the F# test1 project, if that SQL file is not found within the same project, it doesn't, or same like exact same location, so it's expecting it in the same folder or subfolder within the first project. It's going to look for it in the same place in the other project, but it doesn't exist there because it's part of the other project. So because of that, it will break, and so you can't use it as easily. The resolution folder will let you like just say, here's the folder. Like say I put it in the root of my my solution folder. I've got a SQL folder, and all my SQL files will be in there. Then you can specify where what the resolution folder is. Each of your SQL command provider uses. You can see it up here at the top. Resolution folder. So it's just a string, and you just say that go look here for the MySQL files, and then you can use the generated types across projects again, as you could with like the way I'm doing it here, where it's all inline. It's actually quite nicer to use the SQL file because of the IntelliSense, because it makes everything quite a bit cleaner. So I think we'll probably be moving to that, especially now that the resolution folder has been fixed.
Does the project actually not compile if the SQL doesn't compile? That means that it's actually... So then, what if you're working with a shared database and other people are messing with the schema or something, and they end up changing something and you're pointing at that database? How do you deal with that kind of situation with this?
You go yell at them, beat them on the head. Yeah, it definitely does break the build. I'll show. I just changed the letter, so it should start red squiggling here in a moment. But I'll go ahead and build it, and you'll see that it will in fact fail. The same is true if you can't access it.
You really can't control your database for whatever reason, but you know that the code is going to eventually work when they fix the schema. What do you do? Yeah.
So we've actually been working with multiple databases. We have a SQL the SQL database project, and so if we have any changes to the schema, people are supposed to save it into that database project, and then we can apply the changes to our local database and keep working that way. We have like one person who's usually responsible for working against the actual database and making changes there, and that usually is tied in with like real needs of like, and is working with code and fixing stuff as he makes those changes there. And we can make changes if we want to, but it always goes through that that shared SQL database project.
Any other questions? I think we're about all questioned out here and kind of running out of time, so we'll go ahead and start wrapping up.
The one last thing I wanted to show is if you are interested in continuing the discussion further, there is the F# web stack group on Google Groups, and James, if you could pass that URL around, it's just web-stack-fs. And we've got kind of a list of all the different things we're trying to work on at the top in the welcome page. We've got quite a few ongoing threads about like what's going on, how things are working. So if you're interested in doing more F# on the web or seeing what's going on there, then this is a pretty good place to look. I'm trying to get some of these newer tools kind of wrapped up in production ready so we can start using them inside of Tachyus as well.
Very cool. Well, thank you so much for your time, Ryan.
Yeah. Thank you, James, for having me. Thanks for the delays in building.
No worries. Well, have a good weekend.
You too, sir. Have fun in Portland.
Oh, we will.
Trying to get to where I can close the Hangout up.